The majority of life on the planet is based in a food chain which revolves around sunlight. But of course in the deep sea, there is no light. Once you go below 200 meters, light just disappears. That means there are no plants down in the deep ocean. So there is a food chain that operates completely independently. Instead of having sunlight being used as the primary form of energy, chemical energy is used. And that is from these chemical-rich fluids such as methane and also hydrogen sulfide that leak out of the seafloor from fissures that have been formed by tectonic activity. And instead of there being plants, there are bacteria which act as the primary producers, and they utilize this chemical energy in a process known as chemosynthesis rather than photosynthesis, which is pretty amazing. So in geologically active areas such as the Gulf of Mexico, the hydrocarbon-rich fluid and gas can result in a number of unique and rare environments that can range from, a small patch of blackened reduced sediment to cold seeps with extensive mussel beds. Once you see a cold seep, it's just booming with animals. There are thousands upon thousands of animals in some cases, and that's because they've got a really plentiful energy source. So those hydrocarbons seep out of the seafloor, the bacteria then use them, and that bacteria is just constantly being replaced once it's eaten. We've also located brine pools, which is where extremely dense and salty brine seeps out of the seafloor and forms a lake at the bottom of the ocean, which is just amazing. And additionally, we've seen asphalt seeps, where liquid asphalt was seen leaking from the seafloor as droplets. So in the Gulf of Mexico, seep communities tend to be dominated by tube worms and also mussels, which are endemic to chemosynthetic habitats. They are foundation species, and that means they are species that create habitat for other species. And so those tinier species that can be found include Alvinicara shrimp, chitons, eel poutfish, Munidopsis squat lobsters, limpets, snails, the list goes on. These species live here because they can find easy sources of food, they can find shelter, and they can also find hard substrate to attach to. And additionally, you can also find larger predators drifting in opportunistically, such as large crabs, octopus, fish, and so on, that come in to have a quick meal and then go on their way. Further afield from these areas of seepage, there can be hard substrates in the form of asphalt concretions or orthogenic carbonates, and in those areas we can find corals and other suspension-feeding animals using the hard substrate to anchor to, but also to get them up into the water column. So we're exploring for chemosynthetic habitats for a number of reasons. First of all, they are insanely cool, and why would you not? Secondly, they provide us with many ecological services, which a lot of people don't actually realize. They likely have a role in nutrient cycling in our world's oceans. They enhance fisheries. And of course, collecting this kind of critical baseline information about these vulnerable habitats will allow more effective management of the Gulf of Mexico deep sea floor. And lastly, they inspire people. They provide us with a sense of awe, and that's something that really shouldn't be underestimated.